Hi everyone, welcome back to my YouTube channel. And today we are going into details of differentiation, whereby we are going to look at differentiation using first principles. If we consider the curve with a chord PQ in what we call the Cartesian plane. In the Cartesian plane. And when someone talks about the Cartesian plane, we mean X and Y graph. Therefore, I can sketch this. This one stands for my y-axis, and this one here stands for the x-axis. Whereby I label this is y-axis, and this one is x-axis. So I would have a straight line here, and then I draw my chord. This one here is P, and this one here is Q. Therefore, this is the origin. So from origin to this point, this is the y-axis. I'm moving upwards on y-axis. I will have what we call y. And then from this point, I'm moving on x-axis. I will move like this. This one is what we call the x direction. But if I make what we call a small change in respective to y-axis, it means here I will call this one del y, which means the small change in y-axis. And if I make the small change on x-axis, with respect to this position here, I will have a small change, and this one I call it del x. Therefore, the coordinates of P is x, y, and the coordinates of Q, it will be, for x-axis, it will be x plus del x, which is x plus change in x, comma, and then for y-axis, it will be what we call y plus change in y. Now, our main aim is to find the gradient of the curve. I will find first the gradient of this chord here, which is PQ. Therefore, we say gradient of PQ is equal to change in y divided by change in x, divided by change in x. So the gradient of PQ is equal to change in y divided by change in x. And we know that if I have these coordinates, this is P, that is x, comma y, and then Q, which is x plus change in x, and then this is y plus change in y. This is x1, y1, this is x2, y2. The donation, we call this one x1, then this is y1, x2, y2. Dear viewers, I go ahead and therefore, from that very point, I will of course substitute into my formula, which is gradient of PQ is equal to y2 minus y1, which is y2 minus y1, then divided by x2 minus x1. y2 is this one here, which is y plus change in y, minus y1, which is here, divided by y, then divided by x2, which is x, plus change in x, then minus x1, which is x. So here mathematics tells us that it is very normal for us, of course, to cross. Here I will have what we call the change in y over the change in x1, because this x has gone with that and the y has gone with that. This is the gradient of PQ. So I have to introduce a limit. Now, if I want gradient of the curve, so the gradient of the curve will tend to a certain negligible number. Is the same as lim, which is the limit as the change in x tends to 0, then the dy divided by dx is our the gradient of the curve. Therefore, by first principles, to find the gradient of a curve, we normally follow this donation. Ladies and gentlemen, in continuation for the illustration of what we are trying to mean, I will give you here examples about some numbers, and this example here is, so we are going to look at the example, and we say differentiate. Example 1, differentiate the curve. The curve y is equal to x squared using first principles. Using first principles. Differentiate the curve y is equal to x squared using first principles. Now, of course, we shall relate. Being a curve, some viewers may ask themselves that why am I referring y is equal to x squared as a curve? So it is a standard curve which goes through the origin. This is y is equal to x squared, y-axis, and this is x. That's why we refer to it as a curve. We rate the small change in x and small change in y be small increments in both x and y axis respectively. So I relate this one to be small change in x and this one to be small change in y respectively. So from our curve, we shall say y plus change in y is equal to x plus change in x, whereby the whole of this one is squared, because x is squared. Therefore, I will expand this one and I say y plus change in y is equal to x squared plus 2x change in x, then plus change in x squared. So you can bring y this side, then it becomes the change in y is equal to x squared plus 2x change in x plus change in x squared minus y, but y is equal to x squared. So I substitute here and I say the change in y is equal to x squared plus 2x change in x plus change in x squared minus x squared. So this will go with this. I divide throughout by del x becomes the change in y out of change in x is equal to 2x change in x out of change in x, then plus change in x squared divided by change in x. So having done this, I will of course come and continue and say that for that change, therefore, this x will reduce, you will have the change in y over change in x is equal to 2x, then plus the change in x. So this x goes with this x, and one reduces here, you remain with the change in x. So from our formula, that gradient of the curve is equal to limit as the small change in x tends to 0, then we shall have the gradient of a curve. Therefore, substitute where there is the change in x. So where there is del y, del x, I will put there directly the expression. and this becomes limit. At the small change in x tends to 0, they will have 2x then plus 0, because this change in x has tended to 0. Therefore, our gradient of the curve will be 2x. So gradient of the curve is 2x. Dear viewers, this is a trial number that you can try to solve using what we call first principle. This is a trial question that differentiate the curve. Differentiate the curve y is equal to x cubed using first principles. Using first principles. So